Hi everyone. Today I am going to solve previous year's questions in potentiometer. If you want clarity in theory, you can go through the link that I provided in the description. Let us see first question. The length of a wire of potentiometer is 100 centimeter. The EMF of its standard cell is A volt. It is employed to measure the EMF of a battery whose internal resistance is 0.5 ohm. The balance point is obtained at L is equal 30 centimeter from the positive end. The EMF of the battery is, where I is the current in the potentiometer wire. Right. So that means he gave length of the potentiometer wire, he gave standard cell EMF, he gave battery internal resistance, he also gave length over which balance is obtained. Okay. Right. He is asking us to find battery EMF. The potentiometer circuit for this problem can be drawn like this. So this is potentiometer Y. So this is standard cell. He gave its EMF as E volts. Right. So he gave its length. How much? 100 centimeter. So let us say E1 is battery EMF. 0.5 is its internal resistance. Right. He gave current in the potentiometer wire as I. Right. Let us say null point is obtained at a position 1. So that means distance between junction A and 1 is 30 centimeter that he gave. Right. And to balance, what happens? Battery EMF becomes equal to potential difference between A and 1. So that means E1 becomes equal to VA1. VA1 is equal to I into RA1 from Ohm's law. So let us take this as equation 1. Here you can see battery EMF is appearing across a potentiometer wire AB. That means this, standard cell EMF. Okay, this standard cell is appearing across wire AB. That means this EMF becomes equal to potential difference across A and B. So this E is equal to VAB is equal to I into RAB from Ohm's law. When we take equation 1 by 2, what we are going to get? E1 by E is equal to RA1 by RAB. Right. We know that resistance of the wire, okay, is given by expression R is equal to rho L by A. That means RA1, resistance of wire between A and 1 is given by rho LA1 by A dash. Similarly, RAB, resistance of wire between A and B. So that is given by rho LAB by A dash. So when we take ratio, what we are going to get? So this is common. So LA1 by LAB. So RA1 by RAB is equal to LA1 by LAB. Right. So we know LA1 is how much? 30 centimeter. LAB, length of the wire between A and B. So that is 100. 30 by 100 we are getting. Right. Yeah. So when we substitute this into equation 3, what we are going to get? E1 by E is equal to, so what we got? RA1 by RAB, which is equal to 30 by 100. So 30 by 100. So that means E1 is equal to 30 by 100. So that is battery EMF. Which option is satisfying? Yeah, you can see D. D is the answer. Right, let us move to next one. The length of a potentiometer wire is 1200 centimeter. It carries a current of 60 milliamps. For a cell of EMF 5 volts, internal resistance 20 ohm, the null point on it is found to be at 100 centimeter. The resistance of whole wire he is asking. Right. That means he gave length of the potentiometer wire and current carried by potentiometer wire. He gave cell EMF, okay, it's internal resistance. He also gave length over which balance is obtained. Right? Right. He is asking us to find resistance of whole wire. That is the thing. Yeah. We know that at balance, okay, cell EMF becomes equal to the potential difference across length over which balance is obtained. So let us say cell EMF is E and its what is the current is I naught. So that means I become what is it? Cell EMF becomes equal to potential difference across 1000 centimeter. That's what he gave. That is equal to I naught into R 1000, right? From Ohm's law. What is E here? 5 volts he gave. I naught is how much? He gave 60 milliamp, 16 to 10 power minus 3. R 1000, resistance of 1000 centimeter. That's all. R 1000 is equal to how much? So when we take 10 power minus 3, that's it, 5000 by 60. So 0 goes. So 2 3 ja 250. 250 by 3 ohm. So that is R 1000. But what he is asking, resistance of 1200 centimeter. R 1200 is equal to how much? So that is resistance of wire. Rho L, length is almost 1200 by A dash. Similarly, R 1000 is equal to resistance of 1000 centimeter wire. Rho, length is almost 1000 by A dash. When we take ratio, what we are going to get? Yeah. So you can see 12 by 10 means 6 by 5. So R 1200 by R 1000 is equal to 6 by 5. So that means R 1200 is equal to how much? 6 by 5 into R 1000. R 1000 is 250 by 3. Yeah. So 50 into 200. Which option satisfies? Right, D. So D is the answer. Let us move to next one. An ideal battery of 4 volts, resistance RR connected in series in the primary circuit of potentiometer of length 1 meter and resistance 5 ohm. The value of R2 give a potential difference of 5 millivolts across 10 centimeter of potentiometer wire is. Right. That means he gave primary circuit battery voltage, okay, potentiometer wire length and its resistance, and he also gave potential difference across 10 centimeter. Okay, he is asking us to find series resistance R value, right? Yeah, the primary circuit can be drawn like this for this case. Yeah, so this is primary circuit battery. So this is series resistance R. He gave battery voltage as 4 volts, right? Let us say I naught is the current flowing through the primary circuit. Yeah, he gave its length and resistance. Okay, that we can see here. Yeah. Let us say point 1 is at a distance of 10 centimeter from junction A. Right. He gave potential difference across 10 centimeters as 5 millivolts. That means potential difference across A and 1 also going to be 5 millivolts. So VA1 is equal to 5 millivolts. But what is VA1 from Ohm's law? I naught into RA1. Right. So VA1 is 5 into 10 power minus 3. I naught, current in the primary circuit. That is equal to what is that? Primary circuit battery voltage by total resistance in the primary circuit. That is resistance R. As resistance R and potentiometer wire are connected in series, total resistance R plus 5. That's RA1. Yeah, let us take it as equation 1. Okay. RA1, resistance of wire between A and 1. That is given by rho LA1. LA1 is how much? 10. I am directly taken by A dash. Similarly, RAB, resistance of wire between A and B. That is rho into length. Length of the wire is how much? 1 meter. You can see. That is 100 centimeter. That's by A dash. So when we take ratio, what we are going to get? So 1 0 cancels. RA1 is equal to 1 by 10th of RAB. You can see. So 1 by 10th of RAB is how much? You can see. So that is 5 ohm he gave. So right. So let us take equation 2. Let us substitute this into equation 1. So what we are going to get? 5 into 10 power minus 3 is equal to 4 by R plus 5. So this is how much just now we obtained. Sorry, we went 5 by 10. Yeah, no problem. So when 10 goes that side, what we are going to get? 10 power minus 2 is equal to 4 by R plus 5. So this can be written as 1 by 100. So when 100 goes that side, R plus 5 is equal to 400. So R is equal to 395. That's right. Which option satisfies? This is the answer. Let us move to next one. A potentiometer wire PQ of 1 meter length is connected to a standard cell E1. Another cell E2 of EMF 1.02 is connected with a resistance R and switches shown in figure. With switches open, the null position is obtained at a distance of 49 cm from Q. The potential gradient in the potentiometer wire is. That's what he is asking. Right. Yeah. Sorry, we missed one question in between. No problem. First we solve this. Yeah. So that means he gave, yeah, this wire is connected to standard cell E1. So he gave length 1 meter means 100 centimeter. Right. Yeah. He gave a cell E2 with resistance R and switches is connected like this. With switches is open. Okay. That is null point is obtained. The null point is at a distance of 49 centimeter from Q. So that means 51 centimeter from J. You can see. Right. Let us say I0 is the current flowing through the primary circuit. We know that at balance, sub-circuit cell EMF becomes equal to potential difference between junction P and J. So VPJ. So that is equal to what? Right. From Ohm's law, I0 into RPJ. So that means VPJ is equal to I0 RPJ. RPJ rho LPJ by A dash. When we take LPJ that side, what we are going to get? VPJ by LPJ. I0 rho by A dash. Right. VPJ by LPJ is nothing but potential difference across the length. For that length, this is nothing but potential gradient. So, right. But here you can see, here VPJ is equal to E2. Potential gradient is equal to VPJ by LPJ means E2 by LPJ. That's all. He gave E2 value as 1.02. Okay. So when we remove decimal point, we are going to get 100 below. LPJ is how much? 51 centimeter. So 2 by 100, 0.02 volt per centimeter. Which option satisfies? Yeah, that is the answer. Right. Let us move to next question. The current in the primary circuit of a potentiometer is 0.2 amperes. The specific resistance and cross section of the potentiometer wire are 4 into 10 power minus 8 into 10 power minus 1 meters square respectively. The potential gradient will be equal. Right. Yeah. The primary circuit of the potentiometer can be drawn like this. So where AB is potentiometer wire, E0 is battery voltage, R0 is rheostat resistance. Let us say 1 is a point on the potentiometer wire. Right. The potential difference between A and 1 is going to be VA1. That is equal from Ohm's law. Yeah, let us say I0 is the current flowing through the primary circuit. I0 into RA1. So which is equal to I0 into RA1 is resistance of the wire between A and 1. So that is going to be rho LA1 by A dash. So when we take LA1 that side, what we are going to get? VA1 by LA1 is equal to I0 rho by A dash. Right. So VA1 by LA1, potential difference across the length for that length. This is potential gradient. Clear? Yeah. Which is equal to I0 rho by A dash. That's all. We know I0. Specific resistance we know 4 into 10 power minus 7. So 8 into 10 power minus 7. This is. So 2 ja, 1 ja, 0.1 volt per meter. Which option satisfies C? That is the answer. Right. Yeah. Today I solved 5 previous years questions. Thank you.